An integral part of regression modeling is correlation analysis. So if we recall, correlation is a measure of how two random variables or sets of observations of two different phenomena are interrelated. So if you recall the formula for correlation coefficient, it's basically a ratio between covariance of two variables and their standard deviations. And that measures strength of linear association. This is a key word in here, that we are really looking into linear association. So looking at an example, if you have a set of data where you feel like you can draw a straight line in there and the variation of data points around that straight line is relatively small, that indicates strong correlation. And if that line has a positive slope, so then it's a strong positive correlation, and when it has strong negative slope, then it's strong negative correlation. And if you recall, in the previous week we have discussed rank correlation, so that was the case where we may have association between two variables, but not necessarily linear. So there would be a monotone relationship, but not necessarily linear. But in here, when we talk about classical correlation, then we do have in mind the fact that they are actually linearly correlated. So exactly that you can draw a straight line that fits as well the data points as possible. And the case with zero correlation is, for instance, here, where whenever one variable would be changing its value, whichever way, then the second one goes completely randomly with respect to that first one. So in that case, this kind of the slope of this line would be close to zero.